Alright, so here we have a graph of a function. It does pass the vertical line test, you can check that. And I want to find the domain given this graph. So the domain is the set of all inputs that have an output on the graph. So the idea with domain is you want to kind of smash this entire graph down onto the x-axis and then look at where it's shaded. So let's look at this curve here. If I were to smash it to the x-axis, then this point would be shaded, this point would be shaded, and everything in between would be shaded. Okay? Now let's take this next line segment and smash it down. This point's already shaded, so even though this is open, this number, this value on the x-axis will still be shaded because this x value has an output right here. And in between we have x values, outputs for all of these x values, so there's no break on this shaded region here. And finally, the same thing applies here. When I collapse this line down to the x-axis, even though this is open, this x value right here has a y value and output down here, so it stays shaded, and then it continues on to the right forever because this line goes on forever to the right. So our domain is what we see in blue here. The interval notation for that is we read from negative to positive, so negative 1, 2, 3, 4. It starts at negative 4 and goes on to positive infinity with no breaks. Negative 4 is shaded, so we use a bracket, and infinity is never included. We never can reach it, so it's got a parenthesis. So let's now find the range. We do something similar for the range, except we collapse the entire function down to the y-axis, which can be a little tougher because you can have regions that overlap and it can be difficult to see what happens. So let's take a look. Again, you go negative to positive, so let's start with this line segment here. This entire line segment collapses to this single point on the y-axis. Sorry, I don't know why that appeared. Hold on just a second. Okay, there we go. This entire line segment collapses to this single point on the y-axis because this y value has an x value on the graph. Similarly, this point collapses over to here, and since this part of the graph goes up to here for up to this point, I know that I will be shaded at least up to there, regardless of what's going on over here. I just need one point to collapse in order for it to be shaded. Now the question is, what happens here? Do I stop, or do I continue, or what? Well, it looks like I would stop because this part of the graph stops. However, this part of the graph collapses and overlaps it. So now our red line here continues with this part of the graph going up forever because the line goes up forever. And there is our range. Okay? So how do you write this? We've got a single point and then an interval. When we have a single point, negative 1, you read negative to positive on the y-axis as well. We don't use brackets or parentheses. That's when you have intervals. So a single number is enclosed in these braces. Okay? And then we union that because we've got two different regions. They're not connected now, so we have to union them. It starts at a y value of 0 and goes up to infinity. That's an interval, so we'll use parentheses and brackets. 0 is included, so we have a bracket. Infinity is not, so we use a parenthesis. And there are the domain and the range for this function.